So, some of you who were not there on Thursday, like you had your, I think you had chemistry class on Thursday.
Yes, sir.
That day I taught the concept of torque and angular momentum, even the conservation of angular momentum, which I am going to repeat today for you. As well as we are going to discuss some new concepts from this chapter, which I would have not covered in the previous class, which will be useful for both the batch students, that is the studio batch as well as the offline batch. So first let us start discussing about something which some of you may already know, that is about torque. So it can be a revision for the people who were there in the online class last time, and it can be a learning for students who are studying for the first time. So those who don't have the notes for this, give the heading as torque. Okay. So torque is not a new word for you. Reason being, when I taught about the analogy of translatory motion and rotational motion, I said to you what is the meaning of the word torque. Torque is analogous to force. Like how force behaves in translatory motion, same way torque behaves in rotational motion. So basically, torque is a rotating force. A force which is capable of rotating a body is called as torque. So what torque will do? It will create a rotating condition. So if there is an object and you want to rotate it, then we need to apply a torque on it. So imagine if there is an object and you are applying a force in this direction. What will happen if the force is unbalanced? The body starts moving in the front direction, am I right? This motion will be called as translatory motion. So a force is capable of making a body to move in a straight line, or I should say translatory direction. But imagine if I hold, or suppose if I put a hinge here, okay, I put a hinge here and then I apply a force on this direction. Suppose here I am putting a hinge and then I am applying a force, maybe there itself, anywhere. Hinge means the body is allowed to move but not allowed to move front or back. What will happen? If you apply a force here, it will start turning. Do you get what I am trying to say? This condition is called as torque. Torque is a condition where applied force is capable of rotating an object. Write that first, those who are writing for the first time. Torque is force capable of rotating an object. Torque is force capable of rotating an object. Layman's definition, don't write in the examination. It is just to make you understand that it is a rotating force, a force which is capable of rotating an object. Capable of rotating an object. Capable of rotating an object. Force capable of rotating an object is called as torque. Okay. Then what is the professional definition of torque? Write that. Torque is moment of force. Torque is moment of force. Now, whenever I use the word moment, I have told in the previous class to the people who are there in this studio class that moment means you have to, yes, you have to, R cross you should write. That is, R is the position vector and cross you will do. So, if I am writing moment of force, it means torque is R vector cross F vector. So, you can write this mathematically. Torque vector is equal to R vector cross F vector, where R vector is the position vector. R vector is the position vector. It will become clear now, don't worry about it. There is another way I can explain you. If I open this cross, A vector cross B vector is magnitude of A into magnitude of B into sine theta into n cap, right? I hope you know what is A cross B. A vector cross B vector is magnitude of A into magnitude of B into sine theta into n cap. So here what will happen? Torque will become equal to R F sine theta into n cap. This is how we represent torque in scalar form, Rf sine theta n cap, where what is theta here? Theta is the angle between R and F. What is R here? R is position vector, I told you, in vector form. In scalar form, what is R? R is axial distance, or I should say perpendicular distance. Perpendicular distance of the force, of the point of force, point of application of force. Point of application of force from the rotational axis. From the rotational axis. All these things will become clear to you. Let me come with an example. Yeah. One more thing is there, n cap. What is n cap? N cap is the direction of torque. Okay. Anybody can comment on direction of torque from this offline batch I am talking. What is the direction of torque? What will be n cap? Good. So if I write I vector cross j vector, I get k vector. You remember that from the motion in plane topic I taught you? I vector cross j vector is equal to k or k cap. I cap cross j cap is equal to k cap. Why k cap? Because I cross j is in xy plane and k is in z plane. So always the direction of the vector quantity which is found by the cross product of two vector lies in the direction perpendicular to plane consisting this A and B. If I am writing C vector is equal to A vector cross B vector, direction of C will always be in such a way that it is perpendicular to the plane consisting A and B. Are you getting what I am trying to say? That's the reason if I am writing I vector cross j vector, what I get? I get k vector. Because I is in what? What is the answer result for this? If I write I cross j, the result is magnitude of I is 1, magnitude of j is 1, then sine, what is the angle between them? 90 degree and n cap. What is n cap? K. So that's why I cross j came k. So always remember, whenever you are getting a quantity by vector multiplication of 2, then the direction of that quantity lies perpendicular to the plane which consists A and B, in this case R and F. So wherever R and F is there, perpendicular to that direction will be direction of torque. Let all these things become clear with one good example. So that example I gave in the regular class also, previous class also, which is about a nut which is being screwed in the wall or in a wood, wherever you want. So when you are screwing it with the help of a spanner, imagine you are having a spanner like this, something like this, not that good in drawing, fine, somehow. There is a spanner, looks too big compared to the nut, anyhow. So there is a spanner, and by using this spanner, what I am doing? It looks very bad to me. I will redraw. Better. Okay, so I am having this bolt, right, and I am going to tight that bolt. If you wish to tight that bolt, which direction the force has to be applied? Clockwise. So if you apply clockwise, in the sense your force will apply downwards. If you put it down, what will happen? It will lock the nut, isn't it, bolt. And if I apply a force in this direction, open the bolt. Whether the bolt is getting opened or whether it is getting closed, it is either moving in this direction or in this direction, am I right? R is this. Now see, you understand, R is what? Perpendicular distance of the point of application of force from the rotational axis, isn't it? So this distance is called as R. And if I apply a force, maybe, let me take only one example here, that is only downward or upward. So you will realize that when I am applying a force downwards, then this force is capable of rotating the object. So what is the torque here? F, that is R, into F into sine theta. What is theta here? 90 degree. But it is not like you have to apply a force in this direction only. Suppose somebody applied a force like this. Don't you think the body will rotate? It will still rotate. But which component is capable of rotating? Sine theta. This will become, if this is, suppose this is theta, then this will become f sin theta, this will become f cos theta. Don't you think that f sin theta only is rotating the object? That's the reason we write r f sin theta. Another way of understanding this torque. One way of understanding is torque is cross product of position vector and force vector. Another way of understanding is torque will act only with the help of f sin theta. If theta is 90 degree, we directly write f sin 90, so we write f. But even if f is having some angle theta inclined with horizontal, then f sin theta only is capable of rotating the body. So I can write f sin theta into r, which is the same formula which I got here. And n cap represents the direction in which the object is moving. Where it is moving, either out of the plane or into the plane, because r and f are lying on this board. That's why the movement of the object happens either into it or out of it. Is it clear to you? Basic thing. So torque is what? Rf sin theta n cap, where r is the distance between the point at which the body rotates from the application of force, f is the force applied, theta is the angle between r and f, and n cap is the direction of torque, which will be perpendicular to the plane consisting r and f. I hope something is going inside your head. If yes, copy it fast. Whatever you want to copy, please copy it fast. So I told wherever the word moment comes, remember moment means r cross. If you want to copy something, please write it fast. R perpendicular. Both can be there. I have taken here f perpendicular, right? See, f perpendicular is f sin theta. So either if you take f sin theta, you can write r into f sin theta, or you take r sin theta, you can write r sin theta into f. Both are same only, no? So r sin theta is the perpendicular component they are saying. Are you getting my point? If I take r sin theta, it will become r sin theta into f. If I take f sin theta, it will become f sin theta into r. Both are same only. Are you getting f perpendicular or r perpendicular? Got it? Shall I proceed further? Okay. Before talking about your voice is audible, but Karthikeyan, now you are able to hear me? Yeah, I was changing the battery. Yeah, now you are able to hear me, I guess, right? So give the heading as angular momentum. Okay, one more thing I want to say. What is the unit of torque? Force into distance. How much will be that? Newton. What will be its dimension then? Force is ml t power minus 2 into L. So it will become m L2 t power minus 2. These things I hope you remember. Okay. Angular momentum is given by L vector. It's a vector quantity obviously. And once again, it plays the same role as played by momentum, linear momentum in translatory motion. Linear momentum is given by P, small p, isn't it? Small p was momentum, m into v. Here we have angular momentum, which is L. Write definition first. It is the moment of linear momentum. 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 Once again, the moment I say moment of, what it becomes? R vector cross P vector. So mathematical expression for angular momentum is R vector cross P vector, which will make it L is equal to R P sine theta n cap, isn't it? What will be theta here? Angle between R and P. What will be n cap here? Direction perpendicular to plane consisting R and P. Simple, very similar to torque. And for maximum torque, for maximum angular momentum, for maximum L, what will be the value of theta? Theta will be 90 degree. So I can say R will become equal to R into P, isn't it? P will be n cap. I'm just taking the magnitude of it. I'm taking only the magnitude of it. So L will become equal to what into what? R into M into V, isn't it? So can I say that angular momentum is equal to mvr? So angular momentum can also be written as mvr. Again I am repeating, this is going to be used in many places. Angular momentum equal to mvr is going to be used in many places. One more thing, you know that V is equal to R omega from motion in plane chapter itself. V is equal to R omega, velocity is equal to R into angular velocity. So if I put V is equal to R omega, I will get L is equal to m R omega into R, which is L will become equal to mr square omega. What is mr square? I. So L will become equal to I omega, another expression of L. So L can also be written as I omega, and very similar to P is equal to mv. M is I here, V is omega here. So L is equal to I omega. Once again, this formula you would have written when I told you about analogy between translatory and rotational motion. Check your notes, you will have it already. So L is equal to I omega. See, L is equal to Rp sine theta, L is equal to mvr, L is equal to I omega. Anything may be used anywhere. In a numerical, anywhere you may be using any expression. Remember this. Are you getting my point? Based upon the given data. See how the questions are going to come from here, you know. They will give the value of R vector, they will give the value of P vector, and you are expected to write or find the cross product of R and P. R vector is known to you, P vector is known to you. Then when you put in the formula of R vector and P vector, you will be able to get the L vector. Same way R vector will be given to you, F vector will be given to you. Put in the formula of tau vector is equal to R vector cross F vector, get the torque vector. We'll take some questions today to make it more clear. Yes.
What will be the dimension for R?
Dimension for
R.
meter L. R is distance, yeah, it isn't. And what will be the unit of angular momentum? What will be the unit of angular momentum? I am asking unit. Moment was kg meter per second, right? What will be there for this?
kg meter square by second square.
Second square from where you are writing, man?
Kg meter square by second.
Kg?
Meter square by second.
Yes. Actually, it is kg meter per second for momentum. Kg meter per second into meter, it will become kg meter square per second. It is the SI unit of angular momentum. And what will be its dimension then? M L square T power minus 1, isn't it? Okay. If you have written this angular momentum basics, give the next heading as law of conservation of angular momentum. Law of conservation of angular momentum. I am teaching all the theories first, then I will come to numericals one by one. Law of conservation of angular momentum. What does the law of conservation of linear momentum says? Law of conservation of linear momentum, what it says? Loudly. That is m1 v1 is equal to m2 v2, like that, something like that, isn't it? Okay, valid, but when you are in 11th standard, something more is expected. Good. That's how you should say. You should say that if net force acting on the body is 0, momentum is constant or momentum is conserved. How it comes? See here, Santosh, we know that F is equal to dp by dt, right? isn't it? Second law of motion. If P is constant, what will be F? 0. So I can say that when net force acting on the body is 0, momentum is constant. You know, momentum is P is constant, it means what? It means mv is constant, right? If mv is constant, it means what? m1 v1 is equal to m2 v2. That's how the formula has come itself. So remember, when they are asking you about law of conservation of linear momentum, instead of saying like 9th standard before collision, after collision, it is correct only. But the more professional way of saying is, when the net force acting on the body is 0, momentum is constant or momentum is conserved. That is for the translatory motion. Rotational motion, we will write by second law of Newton's second law of motion. By Newton's second law of motion, can I say that torque is equal to dl by dt? Don't you agree? I hope you agree. Like how we have force is equal to dp by dt, here torque will become equal to dl by dt. If torque is equal to dl by dt, and I say if torque net acting on the body is 0, can I say that L is a constant? So I write the statement, those who are writing for the first time. Statement for this is, if net torque acting on the body is 0, those who are writing for the first time, if net torque acting on the body is 0, if net torque acting on the body is 0, then angular momentum is conserved. Then angular momentum is conserved. In bracket you can write constant. I will repeat this. If net torque acting on the body is 0, then the angular momentum is conserved. In bracket you may also write constant. Okay. If L is constant, it means I omega is constant. Do you agree with me? I omega is constant, or I can write I1 omega 1 is equal to I2 omega 2. In many places you will use this. Remember that. Or I can say that moment of inertia is inversely proportional to angular velocity. If you want to increase the angular velocity of the object, its moment of inertia must be small. If you want to reduce the angular velocity of the object, its moment of inertia must be large. Are you able to understand what I am trying to say? Moment of inertia and angular velocity are inversely proportional. If you want to increase the angular velocity, you want to reduce the moment of inertia. I gave an example also in the last class.
Sir, the sign is in directly proportional.
Very good, Sai Aditya. Directly proportional only, but 1 by omega is there, no man? So it becomes inversely. Shall I teach that to you? I hope you know that. If I write I proportional to omega, it means directly proportional.
Yes, yes.
Sure? Okay, fine. Coming back, please pay attention. If you are sitting on a rolling chair, not this chair, okay? And then if you ask your siblings to give a push to you and you will rotate, okay? If you are rotating, you expand your body, your speed will become slow. And you make your body small. How you can make it? By your adjustment of hands and legs. Then your speed will increase. This is seen also in circus, not nowadays. Earlier we used to have circus, grand circuses over the Gemini circus and all. Nowadays also we are keeping, I don't know how much they are doing these things. Park they will have?
I was thinking something, so there will be weights on both sides. If you pull the weight, the speed will be.
Yes, you have gone to some good quality park. They are there, not in normal park. Yeah, Gindi park may be there. But yeah, as you were saying, or like I was saying about circus dancer. So circus, one dancer, if she dances, then when she wants to go very fast, she will make her body to be confined. And when she wants to stop herself, she will expand her body. So she will expand her body to increase the moment of inertia, because moment of inertia depends upon r square, is mr square. M is constant, but r can change. And if r increases, moment of inertia increases, angular velocity reduces. And at the same time, if you make your body small, then I will become less, omega will become more, and you can rotate more faster. Is it clear to you? Is it clear? Copy this and take one question. Valid answer is something else, man. No, don't start to dream something. First you copy it, idiot. Fast, 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 copy it. Those who are writing for the first time. I think this is what we learned in the previous class, right, Sai Vashini? Up to here we learned. And some numericals more which we not did today. Okay. One very famous question, which already some people have done. Don't try to be over smart because you have done. Others, give them chance. Question is, what will happen to the duration of a day? What will happen to the duration of a day? What will happen to the duration of a day? Duration of a day if radius of the earth becomes by half, 1/3. If radius of the earth becomes 1/3. If radius of the earth becomes 1/3. Where you did this question? Oh, you came that day. Huh? Somebody said something.
Can you repeat the question?
Yeah, question is, what will happen to the duration of a day? What will happen to the duration of a day if radius of earth becomes 1/3? If radius of earth becomes 1/3. If radius of earth becomes 1/3. Any answer?
It will decrease.
It will? How much, man? How much times? How much hours? 8 hours. Maybe. Let us check. Anybody else? I hope you realize the question. Normal earth is having how much is the time period? 24 hours, isn't it? One day is 24 hours. Somebody asked last, I think Shri Krishna asked last time. So one day means 12 hours. Somebody asked me, I don't know who was that person. Krishna only.
Sir, in watch he told 24 hours.
Oh, that was different boy. So who told 12 hours in a day? Somebody asked that day.
Sir, 2.66 hours.
2.66
hours.
Let us check. Now the question is, if the earth becomes smaller, radius was r here, now radius became how much? R by 3. Then what is the new time period? That is the question. 24 by? Let us check that. So how to solve this question? I am going to use the concept of conservation of angular momentum, by which I know I1 omega 1 is equal to I2 omega 2. I hope you know and you have learnt what is the moment of inertia of solid sphere. 2 by 5 mr square. You remember? If you don't remember, check your notes. It is 2 by 5 mr square omega 1. What is omega? Those who don't know, omega is 2 pi by t. Omega is angular velocity. It means 2 pi by t. How it came, you know? What is the meaning of angular velocity? Rate at which the angular displacement is changing. If you see one full circle, how much angle is covered? 2 pi angle. How much time? T time. So 2 pi by t will become angular velocity, isn't it? So if you write here 2 pi by t or t1 you write, t1 r1 is equal to what is I2? 2 by 5 m r2 square into 2 pi by t2. Solve this, get the answer. 2 by 5 m, 2 by 5 m cancels, 2 pi cancels. What is r1 square? Normal r square by what is t1? 24 hours is equal to what is r2 square? R2 is r by 3. So r by 3 the whole square. And what is t2? You want to find that. So r square by 24 becomes r square by 9 times t2. So r square it's cancelled. T2 as somebody told already 24 by 9 hours. Whatever comes. Whatever. This is the answer. Are you understanding this question? This kind of question can be quite expected in the examination. Not a big question. In the last class, I even solved a question where they talked about volume of two objects. If Earth's volume becomes one third, 1/4 like that. So if the volume is changing, you have to compare with the help of 4 by 3 pi r cube. Don't confuse in that. Okay, is it clear to everybody? Anybody has doubt in this? Anybody? Offline, Lalit, Lakshita and Karthikeyan. If any doubt is there, feel free to ask me. If no, we are going to enter into a new concept. Shall we start that new concept? What new concept is there? Shall I start that? Shall I? Okay. Give the heading as theory of moments. Now nobody would have learned this, so everybody should learn this. Give the heading as theory of moments. Or principle of moment, whatever you call it. Theory of moment or principle of moment. Whenever I am using the word moment, I said you it is r cross, isn't it? Yes or no? Moreover, see, this topic is really important, really important, and this can only trouble you in this chapter. There are some questions in NCERT example exercise where they have used theory of moments. We will solve all those questions now in the class after I teach you the concept of theory of moments. So when I say moment here, basically I am meaning torque, understand that, okay? When I am using the word moment here, I am meaning torque. You know that, please pay attention, everybody be in the class now. You know that if a body wants to be in translatory equilibrium, the net force on the body should be 0, right? That is, if you have an object, this side force is there, this other force is there, but they are same forces. It means what is the net force? 0. The body will be in equilibrium, it will not move anywhere, isn't it? So if you want the body to be in equilibrium, net force acting on it should be 0. Same way, if you want the body to be in rotational equilibrium, net moment should be equal to 0, net torque should be equal to 0. Write that. For an object to be in rotational equilibrium, everybody please take the notes properly. For an object to be in rotational equilibrium, net moment, in bracket you can write torque. For an object to be in rotational equilibrium, in bracket you can net moment, in bracket you can write torque. Net moment, in bracket you may write torque, must be equal to 0. Must be equal to 0. Must be equal to 0. In other words, clockwise moment must be equal to anti-clockwise moment. Clockwise moment must be equal to anti-clockwise moment. This is called as theory of moments. Clockwise moment is always equal to anti-clockwise moment. For what? For a body to be in rotational equilibrium. It means if net moment is not 0, the body will rotate. Are you getting my point? If a body wants to rotate, it means its net moment is not 0. Either clockwise is more or anti-clockwise is more. If one of the moments is more, then the body will not be in rotational equilibrium. Okay. Theoretically it's so fine. You may have problem in some numericals from it. So let us take NCERT book and come to example 6.8. One very good question is there. Example 6.8. I'll open the book here itself. How I search here? Physics 11th, then NCERT. What is chapter?
System of particles.
Number yaar.
6.
Chapter 6 PDF. Huh? I hope it will come. No network. Example 6.8. If you have the book, open the book. Come to example 6.8. If you have the book in your hand, open the book. Example 6.8. We'll do it now. What is the page number here?
113, sir.
One not?
113.
113.
Sir, 6.7, you will go a bit. We can 6.6.
6.8 I told, no? Huh. Is it hot or cold? Hot or cold? Cold for you. Hot for you. You're sitting in. One second. I'll reduce it. Guys, 2 minutes, man. All of you are able to see the question? A metal bar 70 centimeter long and 4 kg in mass supported on 2 knife edges placed 10 centimeter from each end. Okay. A 6 kg load is suspended at 30 centimeter from one end. Find the reaction at knife. Actually, this question is little complex for you people to start with. Let us try. Let us take a tough question and solve it. So let us draw the diagram calmly. They have given the diagram also, by the way. A metal bar 70 centimeter long and 4 kg in mass. So I am drawing it over here. There is a metal bar. How much long they told? 70 centimeter long. And what is the mass of it?
4 kg.
4 kg mass. What else is given?
6 kg load is suspended.
Supported on a 2 knife edges placed 10 centimeter from each end. It means that here and here I have 2 knives. Do you understand? And how much is it away from the edges? 10 centimeter both sides. This question is going to teach you many things. Be very alert if you want to understand this question. Next, what they told, 6 kg load is suspended at 30 centimeter from one end. So from one end I will go 30 centimeter and I am going to put a load down. How much is that? 6 kg. Yeah? 6 kg is hanging from 30 centimeter from there. Okay. Huh.
It is from the edge or from that wedge, sir?
Wedge. Yeah.
I mean, sorry.
30 centimeter from one end they told, man. End.
Okay.
End, not knife.
Okay.
Okay. Find the reactions at the knife edges. That is the question. Reaction means what do you know? Action, reaction. When you have some mass on 2 knives, for sure both these knives are going to give some reaction, isn't it? You can take N1 or if you are comfortable with N1, let us take N1 itself. Normal reaction. N1 and here it is N2. They are asking you to find the value of N1 and N2. First of all, I will ask you, where do you think the 4 kg mass will be concentrated? At the center? Center of gravity. See, center of, one topic is there in NCERT separately, center of gravity. Center of gravity and center of mass are most probably the same points until the center of gravity is, the gravitational force is varying. For example, if you take me, I am standing here, my center of mass and my center of gravity are going to be same. But if you compare something where the gravity is changing, for example, if I am moving from here to Mars, my gravity will be changing. That time my center of gravity will change, but center of mass will remain same. I hope you are getting my point. Center of gravity is defined as the point on the object where whole weight of the body is concentrated, and center of mass is the point on the object where whole mass of the body is to be concentrated. Generally, if the gravity is not changing, center of mass and center of gravity lies in the same point. Whereas if gravity is changing, if I go to space, my center of gravity is 0. Are you getting what I am trying to say? But my center of mass will remain the same wherever it lies. So center of gravity depends upon the gravity obviously, and center of mass does not depend upon the gravity. It is constant everywhere. I hope you get my point. But generally, center of mass, center of gravity are same. So for this case, center of gravity will be lying in the center of it. What is the total length here? 70, 35. So 5 centimeter from here. What will be there? The 4 kg will be there, isn't it? So 4 kg is going to be 35 from here. All these distances are very, very, very important to understand. There are many forces acting here. 6 kg, 4 kg, N1, N2, isn't it? I will take another question now, which will have much more forces than this. A ladder question is there. Next, 6.9. We will solve that question also now. But before I go to the ladder question, understand this question. This is bit easier than that. Now here, if you see this metal bar lying on the two knives, it is in translatory equilibrium, right? If it is in translatory equilibrium, it means for equilibrium I am writing. For equilibrium, can I say that total mass is how much? 10 kg. So N1 plus N2 must be equal to, if I want to write in newtons, it will be 60 newtons. And this will be, I am taking G as 10, okay, not 9.8. So can I say N1 plus N2 will be 100 newtons? Anybody has problem in this? White right, and it will confuse you. If you have problem, ask me now itself. How the equation came? Total downward force is equal to total upward force. Downward, how much force is acting? 60 plus 40. Upward, how much is acting? N1 plus N2. So N1 plus N2 is equal to 100. Are you getting what I am trying to say? If this 6 kg mass would have not been there, I will write N1 plus N2 is equal to 40. Do you agree with me? Okay. Ask me, Lalit. I expected, yeah. Ama. Why you are not coming for offline class, man? Coming back here. This diagram is clear to you, Lalit? Is this diagram clear to you?
35 centimeters.
35 centimeter is the point at which the weight is concentrated. Total weight is 4 kg, Lalit, and total length is 70 centimeter. So at 35 centimeter, its center will lie, isn't it? Unmute and say yes or no, man.
Yes, sir.
Total length is 70 centimeter. What is half of 70 centimeter? 35, right? I hope you have mouth. Say yes or no, man. My mic is working, right? Are you able to hear me? Sivesh, Indumati, everybody?
Yes, sir.
Lalit Ramna.
Sir.
Did you understand how this 4 kg came in 35 centimeter?
Yeah, network issue.
Okay, man. After the class gets over, you wait for some time. I will separately teach you all these things, okay? Don't worry about it. Now focus here. Okay, now please everybody pay attention. So I said that N1 plus N2 is equal to 100. Everybody is clear in this? Any problem is there, please ask me now itself. Now I will talk about the moments. Now please pay attention. You know very well, just now we have learned before some time, torque is equal to force into perpendicular distance, right? Now, there are 4 forces acting here. N1, 60 Newton, 40 Newton, N2. If you see, you will realize that the moment produced by N1, see, first of all, understand this, I'll tell you. When you want to calculate the moments, you should calculate the moment at a particular point. Now you may ask me, so can we calculate here, 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 or anywhere? Anywhere actually, your wish. For simplicity, where you want to calculate? Shall we calculate here? Huh? We can, no problem in that. If we calculate here, then N1 will produce a moment like this. Is it clockwise or anti-clockwise? This 6 kg will produce like this, clock or anti-clock? This N2 will produce like this, clock or anti-clock? But 4 kg will not produce any moment because the point itself is 4 kg. If some student says, no sir, I will take this point, N1, you can take, no problem. This 6 kg will produce a clockwise moment. This 4 kg will produce a clockwise moment. N2 will produce a anti-clockwise moment. I'll say one more example to you. If somebody says, no sir, I will take here, take. This N1 will produce what moment? Clockwise moment. 6 will take how much moment? Anti-clockwise. 4 will take what kind of moment? Anti-clockwise. If this you are understanding, it is done. How I am taking moment, is it clear to you? If yes, then which point shall I take now? Tell me, for solving. 6 kg.
Sir, can you repeat once again?
I will repeat here. You can take the moment at any point, Srinidhi, okay? Any point. I can take here, I can take here, I can take here, I can take here, or I can take anywhere. Why I can take anywhere? Because the body is in equilibrium. Net moment should be 0. It is neither rotating like this nor like this. It is at rest. It means net torque is 0. If net torque is 0, at any point if I take, the moment should be 0. So suppose, Srinidhi, if I take this point, is it visible to you what I am drawing?
Yes, sir.
Okay. So at this point if I take, this 6 kg force, that is 60 Newton force, will produce what kind of moment? What is the direction? Clockwise. This 4 kg will produce clockwise. N2 will produce anti-clockwise.
Anti-clockwise.
Are you getting my point? So in this case, tell me now, what are the clockwise moments? Clockwise moments will be 60 into what is the distance from here to here? Be careful in that. This is 30 and is 10, it will be 20, isn't it? 60 into 20, do you agree with me?
Yes, sir.
Okay, then plus, what is this? 40 into how much? This is 5 and this was how much? 25. So can I say 40 into 25? Do you agree with me?
Sir, can you repeat once again?
From where, Tambi?
Sir, that 60 minus 40, you will repeat it.
60 minus 40, where I wrote, man?
No, sir, that 60 to 20, sir.
How I wrote, you are asking?
Yes, sir.
Yes, listen. 60 is the force downwards, right, Karthikeyan? And we are finding net moment here. So the perpendicular distance of 60 is how much from here to here? Totally is 30, this is 10, this will become 20.
Yes, sir.
Same way, this 40 Newton force is how much far from this point? This is 20 and this is 5. So 25.
Yes, sir.
These two are what moments? Clockwise moment. This must be equal to what? Anti-clockwise moment. What is anti-clockwise moment here? N2 into what? From here to here, what is the distance? Find. 50. Yeah, 50. Because 10 subtracted, it will become 50. Correct. Now you solve this, you will get the answer. So how much came? 1200 plus 1000 is equal to 50 N2. So how much is that? 2200 divided by 50 becomes N2. How much is that? 5 4s are 20, right? 44. I am getting N2 as 44. If I am getting N2 as 44 newtons, what will be the value of N1? 66, good. 56 newtons, isn't it? Or I can say 4.4 kg and 5.6 kg. What is the answer given, Sai Varshini? In the book, what is the answer given? Okay, so I have taken 9.91. Approximately same only. Leave what the book has done. See what I have done. Are you able to understand this? If any doubt is there, feel free to ask me. How? N1 plus N2 is 100. Or N2 you found 44. 100 minus 44 is 56 if I am right. Got it? Is your understanding? This is rotational mechanics, simple thing. Yeah. Tell me, Lalit, man. Loudly, man, loudly. Guys. Man, from beginning till the end, you should be louder. Don't be louder, please, please, please. Guys, everybody silent. I'm hearing him. Yeah.
Sir, 20 and 25 against something.
20 and 25 எப்படி வந்துருச்சு இது வா தம்பி சரி பாரு guys, those who have understood can start writing it. I am teaching to Mr. Lalit Ramna. Okay, Lalit, this 20 and 25 has come by the diagram, geometry. They have given total, I am drawing once again for you, please pay attention. Total length is 70 centimeter. Okay, Lalit?
Okay, sir.
You unmute and say okay. Then total mass is 4 kg, right, Lalit?
Yes, sir.
This 4 kg mass is concentrated in the center of the scale. If total length is 70 centimeter, what is its center, Lalit? Tell tomorrow. 35. Good, yeah. Be confident. So 70 is total length, middle will become 35. So this 4 kg is hanging at 35 from the end. Right, Lalit?
Yes, sir.
So 4 kg means 40 newtons. You are okay with this?
Yes, sir.
Okay. Next is, my knife is lying, they have told in the question, 10 centimeter from the end. This is 10 centimeter and this is also 10 centimeter. Okay, Lalit? Okay, now pay attention. If this is 10, this is 35, what will be this distance? Tell me, you tell me. 35, 10. What will be this?
25.
Very good. You understand how 25 came here?
Yes, sir.
So 40 is acting at 25 centimeter from there. Understood?
Okay, sir.
Next they gave 6 kg mass is hanging 30 centimeter from the end. Okay? So what I am going to do? I am going to hang a 6 kg mass, that is 60 Newton force, where 30 centimeter from one end. So from one end I am going where? I am going 30 centimeter. Lalit, this is 10 centimeter, right?
Yes, sir.
So what will be this distance, tell me?
20.
Understood how 20 came?
Yes, sir.
Puri Daipo?
Yes, sir.
Thank you. Anything else you want to ask?
Nothing, sir.
Okay. Is it clear to everybody? Basic geometry and some concept of torque we have used here, nothing much. Sure, clear?
Yes, sir.
Nobody has doubt? Can I take it for granted you have understood this? This is the level of question which is starting of JE level, starting, very basic. Let us go to little more higher level, little more higher. Fast man, please, time is not there. Already 8:30 is going to happen. If you are copying, make it fast. And those who have done copying, if you have book in your hand, take 6.9 example, fast. Example 6.9. Huh? I'll take it here, man. They are copying, that's why I'm not opening it here. Let them copy, then I'll open the book. Example 6.9, make it fast. He's getting? What shall I do? Tell me.
Increase in temperature.
How much shall I make? Tell me.
20.
How will you go, man? Have you seen the arrangement? You'll be able to go.
28 or 27.
Actually, you are sitting in a place where the maximum AC is coming. That's the problem. Okay. Come fast, Santosh. Raghav, can I go to the next page? Huh? Thank you. Don't become emotional, okay? Yeah. Now see this question. Don't try to see what they have given in the answer. You will not understand. NCERT book, okay? Do by yourself. It's a good question, complicated question, little bit complicated. Visible to everybody? Is it visible to everybody? They have told a 3-meter ladder weighing 20 kg leans on a frictionless wall. Its feet rest on the floor 1 meter from the wall as shown in the figure. Find the reaction forces of wall and floor. Great. Is the question clear to you first? They have taken a stair and they have kept the stair on the wall. Stair is having a length of how much? A ladder stair, same 3 meter. And 3 meter long ladder is kept 1 meter away from the wall. When it goes like this, why they have used the word frictionless wall, you know? There is no friction here. Only one force, reaction force of the wall. Down they have not used the word frictionless floor. They cannot use, it will slip otherwise. Friction is there down. So what they have told, they have given the F friction here also. See, friction is inside, normal is above, F2 will act in this direction. Obviously, because there are two forces, it will resolve itself. They are asking you to find this F2 and F1. Is the question clear to you? What they are asking is clear to you? They are asking the reaction by the wall and they are asking the reaction by the floor. Why the reaction of the floor is not normal? Because there are two forces acting. One is normal force, one is frictional force. It will resolve in this component, which will become equal to root of n square plus f square plus 2 into f into 90 degree. That is n square plus f square only. If your basic is weak, this question you will not understand. If your basic is having some knowledge, then you will understand this question. Shall I draw the diagram on my board? Little better diagram. So how the question is, please pay attention. There is a wall here. I'll use some geometry box, no? Okay, this much I don't have, leave it. Leave it, I will do by hand itself. There is a wall and this is the floor. I have a ladder. One meter away from the wall. Three meter is the ladder height. What they are asking you to find? This wall will have a reaction here. Why? Because there is no friction involved in the wall. This they have asked you as to find as F1. Since there is a friction involved in the bottom, you may realize that this ladder will try to go that side, isn't it? By slipping. If you try to stand on the ladder, if you want to fall down, it will go back, right? So if it is trying to go back, there is a frictional force going to set up in which direction? Do you agree with me? And obviously there will be normal coming here. Since there are two forces, one is frictional acting in this direction and normal acting in this direction, net force they have given as F2, which will become equal to root of n square plus f square. Any difficulty in that? So they are asking you to find that only, this thing which is F2. Okay. I am not writing F2 now because it is complicating my diagram, it is making it look more nasty. First of all, like the previous question, even here, the center of gravity or center of mass will be in the center of the ladder. So 3 means 1.5 acting downwards. How much is the mass of ladder? 3 kg. 3 kg ladder है 20 kg 3 kg ladder if you 20 kg ladder is there 20 kg ladder is there which is thank God they have not given in the question a man is going on the ladder and trying to take out something from the up, then the reaction will be more complicated. Now only one thing is there, only the weight. No man is standing on the ladder. Okay. Now as I said to you, for the body to be in rotational equilibrium, net moment should be 0. Since the ladder is not moving right, left anywhere, net moment should be equal to 0. How can net moment be 0? Anti-clockwise moment, clockwise moment should be same. First of all, let us try to find out what are the moments acting here. We will take this point. You know why? Easy. So one force is this F1. For this F1 force, what is the direction of moment? Anti-clockwise. Anti-clockwise, right? Don't say, sir, I will take like this. Some of the fools are there. They will say, sir, I will take like this. Became clockwise, no? You should not change the direction of force. What?
I took the ladder right side, sir.
You took it like this, sir. Okay, then also you will get the same answer only. Your direction of friction will change, no? Anyhow, so F1 will become which kind of moment? Anti-clockwise moment. Do you agree with this? And this 20 kg will give what kind of moment? But for this F1, the distance is how much? Root of 3 square plus minus 1 square, right? See, force into perpendicular distance. Never forget that torque. So don't take F and take 1 meter. Not like that. This is the force. What is the perpendicular distance? I hope you get my point. Same way, this 20 kg, what is the distance? 0.5. Acting in the center, no? So 0.5. I hope. Isn't it? So what will be the equation? Equation will be, I am writing it here, F1 into, what is the value of that distance here? Root of 9 minus 1. Root of 8 becomes 2 root 2. Good. So F1 into 2 root 2, nothing else, right? Anti-clockwise, nothing else, is equal to F into, sorry, not F, sorry. 20, like 200, because 20 is a weight, mass. 20 into G, 200 into 0.5. It will help me in finding F1. N1 is still to be found, we will talk about that. So what will be the value of F1? F1 will become equal to 200 into 1 by 2 divided by 2 root 2. 2 to 4, 450. 50 by root 2, that is 50, 25 root 2, isn't it?
25 root.
Sir, how the 0.5 came?
How 0.5 came? Totally is 1 meter. It is acting in the center, 0.5. Got it, Ashwath? Sure? So it will become 20. What is this here? (25 root 2 newtons) is the value of F1. Check in the book, same thing is given. F1 is same as what I got or something else? F1 is same as what I got or different? 20? Multiply, it will come. If you do 1.4, it will come as what is given in the book. Okay, fine, correct. Now to find the value of F and F2, F2 we can find only if we have the value of what? N and F. See, it's simple why I am saying. Pay attention. For the body to be translatory equilibrium, upward force must be equal to downward force. What is the upward force? N. Downward force 200. So I can say N is equal to 200 newtons obviously. And what is the friction? F1. So can I say F is equal to F1 is equal to 25 root 2? So what will be F2? F2 will become equal to root of 200 square plus 25 root 2. When you solve, you will get the answer. Are you getting how I have done this? I'll explain, pay attention. How frictional force is 25 root 2. Please pay attention. If the body wants to be in translatory equilibrium, net downward force, net upward force must be same. Net force acting in the right, net force acting in the left must be same. See, if I am standing here, I am in all the equilibrium, translatory, rotational, everything I am there, equilibrium. It means whatever force I am giving down, mg, is equal to n. And assuming somebody tries to push me from here and somebody pushes me from here, they both also same, then only I can be at rest. Are you getting what I am trying to say? In this case, my ladder is not moving. They have told in the question itself. It means whatever force is acting in this direction definitely is cancelled by this direction force, right? And whatever force is acting in the upward direction, it is cancelled by the downward direction. Net downward force, what is visible to you here, man? Only one force is visible. What is the upward force visible here? Only n. They both must be same for equilibrium. Same way, what is the force acting towards right? Frictional force. Nothing else is acting towards right. And what is acting towards left? F1. So F must be equal to F1. That's why I wrote 25 root 2 as F. Loudly. See, that is with respect to, if I want to take minus, it just indicates that it is acting in the opposite direction, and if you do minus, it will become square of become plus only, no. If you take minus 25 root 2 and make it square, it will become plus only, it never matters. I hope you are understanding this. So when you solve, you will get the answer. Is it clear to you? How much ever complex the question may look, if your concept is clear, it becomes simple. Believe me, it may sound it to you very complex question, but it is very simple question, most probably simpler than the previous question, in terms of solving at least. Here we had more steps compared to this one. Is it clear to you? Any problem, please ask me.
Sir, what if the question comes like a man of weighing 80 kilos climbing the ladder?
Then you have to find where he is present at that time.
He is present at 1 meter.
From where? Bottom?
Yes.
Making your own question.
Climbing in the ladder, 1 meter.
Okay, here shall I make him?
Yes.
Then his weight lag downwards, isn't it?
Yes, sir.
So I will consider that also, and I will find the moment. So what will happen in the clockwise moment? One more thing will get added up. If his mass is 80 kg, yeah. So 800 into whatever it comes, 1 meter here. So we accordingly by using Pythagoras theorem we can find the value of this and we can solve it. Are you getting? Just an additional moment will come, and what will happen? Upward force will also change. It will become n is equal to 200 plus this force, 800. Are you getting? So n will change. I hope you are getting my point. Okay. If you are done, all of you are done. Will you do today? Exercise question 6.9. I'll wait here. I'll wait. Those who are done, for them I told. If you have done this, exercise 6.9. One more thing I want to discuss with you: motion of center of mass today. After this question, I'll discuss that. 25? Whatever one, leave that. Go to the next question. Have you copied from the board? Satvik, exam starts Friday. This chapter is there, no? Cases of partial equilibrium. What is that? That is there in the portion.
Last class we discussed now, sir. If possible, could you recapture?
I'll do it. Have you done it? If you are done, exercise 6.9. Shall I go? See, in this chapter, I have not gone in NCERT order. I have taught you as you understand well. So suppose I have taught angular momentum before, here the angular momentum is last topic, don't confuse by that, okay? I have taught everything but not in the order. I have gone in my own order. I talked about 6.9. Even 6.8 you can try, simple only. But first do 6.9. Question is simple, in front of you. A car weighs 1800 kgs. Distance between its front and back axle is 1.8 meter. Quite less. Okay. Its center of gravity is 1.05 meter behind the front axle. Determine the force exerted by the level ground on each front wheel and back wheel. Good question. Assuming that all the wheels have same mass. You have to use theory of moments only. Car is small because generally the car will be 4 meter long.
1800 kg.
That is not that small. And after axle there will be some engine part also, no? Engine part here and behind dicky part. Assume it is sedan car.
Say 1.8 meter from the back and front axle.
Axle means where the tires are there, no? That is called as axle.
From the first tire, 1.8.
Back is a back tire. I will draw it for you, man. From here to here. Are you solving or enjoying? This is 1.8 meter. Understood? And they are saying center of gravity is 1.05 meter behind the front axle. Oh my god. Engine is lying behind. Because 1.05 meter behind is center of gravity. It means more mass is behind, less mass is front. Usually it will not happen. Usually front only will have all the mass. Anyhow, we will not bother about that. Center of gravity is lying somewhere here. Center of gravity means what? All the weight will lie here. Which is equal to how much? 18,000 newtons. Loudly? Center of mass, center of gravity will be same because car is moving on the earth only. Are you getting? G is not changing, man. It is not going to space. Determine the force exerted by the level ground on each front. So what they are asking is this thing. Reaction, isn't it? Is the question clear to you? Question is simple actually. But one thing, whenever you find the N1, N2 value, divide by 2 because there are two wheels in the front and back. I hope you get my point. Diagram is clear to you. They have told the distance between front and rear axle. Axle means that rod which joins the two wheels. So between the front and the back is 1.8 meter, and they have told the center of gravity is 1.05 meter from the front axle. And what they are asking you to find? They are asking you to find the force exerted by the ground on each front wheel and each back wheel. It means N1 and N2 they are asking you to find. Since we have two wheels in front and two wheels in back, whenever you get the value of N1, divide by 2 to get the correct answer for each wheel. Are you getting my point? Let us check whether it is same. It will not be same for sure because it is not in the center position. I will draw the diagram in the board also. That's all, isn't it? What they're asking you to find is N1, N2 value. What I'll take? I'll take moment at this point as 0. 0 means same. So what will be the moment? N1 into 1.05. Okay, we can solve like this also. Is equal to N2 into 0.75. Good. And also we have N1 plus N2 is equal to how much? 18,000. Isn't it? Net upward, net downward are same. So I can write the value of N1 as N this much minus N2. 18,000 minus N2 into 1.05 is equal to N2 times of 0.75. If you solve properly, you will get the value of N2. If you put the value of N2 here, you will get the value of N1. So force on each front wheel will be N1 by 2. Force on each back wheel will be N2 by 2. Assuming that there are two wheels only. Yeah.
Sir, if you take N2 equals 18,000 minus N1, that will be easy one.
Your wish should take if that is easy for you.
Calculus.
Your wish, man. Do it. I don't have any problem in that. You are feeling cold or you are feeling hot? Cold. You are feeling cold. There are more people in the room. If I cannot off also, it will become very suffocating.
Just after 5 minutes.
See, there is no circulation of air in this room. Are you getting my point? The problem is that. Okay, 2 minutes I will off. Don't worry, time is almost 8:46. 10 minutes more, 15 minutes more only. Is it clear to you how I solved this question? See, theory of moment is clear to you or not, guys? Loudly.
This question, how can I explain again, sir?
I can explain, man. What they have given. Looks like a car. Okay, so they have told that the front and the back axle is separated by how much meters? They have told the whole mass of the car is lying 1.05 meter from the front axle. How much is that? 18,000 newtons. What they're asking you to find, what is the force given by the ground on the wheel? This is the question. Yes. So I have drawn this thing in a free body diagram where I have taken the front axle N1, back axle N2, center of gravity 1.05 meter from here, acting downwards. So net upward N1 plus N2 is equal to net downward 18,000. I am finding moment at this point. So when I am finding moment at this point, N1 into 1.05 will give me moment here, right? Clockwise moment. N2 into 0.75 will give me anti-clockwise moment. How 0.75 came? 1.8 minus 1.05, right? So N1 into 1.05 must be equal to N2 into 0.75 if the body wants to be in equilibrium. Then I solve, I'll get the answer. Understood? Yes, Bharat.
One is 7,500 and another is 10,500.
You are talking about N1 N2 value or divide by 2 you did? So divide by 2 you will get the exact answer.
Divide by 2 also.
Obviously there are two wheels in the front, no? They are asking for each wheel, not the axle. Is it clear to everybody? Anybody online, anybody has doubt, you can ask me. Sivesh, understanding?
Yes, sir.
Soumya, what about you? Understood?
So it's front wheel 3,750 Newton. The back is 5,250 Newton.
Check in the book back, it is matching.
1.05 meters.
Almost matching. Yeah?
1.05 meters. What distance?
It is the distance of center of gravity. There only the mass is concentrated, weight is concentrated. They have given the question itself. Got it? What, Raghav? What problem you have? Ask me, I'll help you.
Sir, I can't understand what you're saying distance.
Distance as?
From axle to center of gravity and then from front and back axle. I can't understand.
See man, distance between its front and back axle is 1.8 meter. Its center of gravity is 1.05 meter behind the front axle. What I am doing, you see? Distance between the front and the back axle I am taking as 1.8 meter. And I am putting center of gravity as 1.05 meter from the front axle. This is the front axle and this is the back axle. Understood? Sure? Shall I proceed further? So one thing which I have, I think I have not talked about this in the class previously, which is about motion of center of mass. Please guys, 10 minutes more I will take. Be attentive. Shall I, Nikhil? Please pay attention. So I not talked about motion of center of mass. I spoke about center of mass to you. Center of mass can be found by the formula m1 r1 vector plus m2 r2 vector by m1 plus m2 and so on. I talked about this, right? If you want to find center of mass for a given object, the center of mass location is m1 r1 vector plus m2 r2 vector plus m3 r3 vector m1 rn vector by m1 plus m2 plus m3 plus m4 like that. If it is a two body system, m1 r1 vector plus m2 r2 vector by m1 plus m2. Have I taught all these things to you? I hope you remember that. In some schools they are doing x and y separately and doing it. I did like r1 vector and r2 vector to save your time. You remember all these things? Absent in that class? No means you were there. Okay. Behaving like what you are speaking. Understanding what I am saying? If the object is in motion, then center of mass will also be in motion. And in that case, the center of mass will have a velocity. And velocity of center of mass can be found out by the formula m1 v1 vector plus m2 v2 vector up to mn vn vector by m1 plus m2 up to mn. Remember this. Nothing big. To understand this, let us take one small simple question. Take one question. Take one question.
Sir, is this relationship like a relation between? Oh, okay, nothing.
Shall I give the question? Just to give you confidence about how the questions can come from here. Question is, please take a question. Two particles of masses 100 gram and 300 gram. Two particles of masses 100 gram and 300 gram at a given time have positions 2i cap plus 5j cap plus 13k cap and minus 6i cap plus 4j cap minus 2k cap respectively. I have written on the board also. First one is 2i cap plus 5j cap plus 13k cap. Second one is minus 6i cap plus 4j cap minus 2k cap. Obviously in meters, everything is in meters. And velocities 10i cap minus 7j cap minus 3k cap. Everything is on the board here, copy from here, okay. 10i cap minus 7j cap minus 3k cap and 7i cap minus 9j cap plus 6k cap, obviously meter per second respectively. Determine the center of mass and its velocity. Determine the center of mass and its velocity. Direct question, formula based. m1 is given, m2 is given, r1 vector is given, r2 vector is given, v1 vector is given, v2 vector is given. I think nothing is required to be done. Just put in the equation, get the answer, isn't it? I hope you understand what I have told now. m1 r1 vector plus m2 r2 vector by m1 plus m2 will give you RCM. m1 v1 vector plus m2 v2 vector by m1 plus m2 will give you VCM. Over. I hope you understand what I am saying by words. Do you understand this?
Can you repeat the formula?
What formula I told I have written here, man, for velocity, and for position of center of mass, RCM vector is equal to, this I told in the previous class also to you, m1 r1 vector plus m2 r2 vector up to mn rn vector divided by m1 plus m2 up to mn. Okay, Karthikeyan? So by using this formula you can find center of mass, by using this formula you can find velocity of center of mass. Is it clear to you?
Yes, sir.
Okay. You can solve it later. I think only multiplication thing is there, nothing big is there. Let us talk one last topic before I close today's class, which is about what she was asking. The heading is equilibrium of rigid bodies. Equilibrium of rigid bodies. Basically, 2 minutes please, everybody pay attention. It is an object, and this object, as I said before some time, is acted upon by two forces which are equal, opposite and acting at the same point. Will the body have any motion? Obviously not. F minus F will become 0. So the net force on the body is how much? Net torque on the body is how much? Obviously 0. How torque can be there? For torque to come, there must be a force and there must be a perpendicular distance. So body is said to be in rotational equilibrium as well as in translatory equilibrium. So body is in translatory equilibrium also, body is in rotational equilibrium also, and the body obviously will be in a state of rest. Do you agree with me? Do you agree with me? Same object, if acted upon by a force, a pair of force which are unequal, now what will happen? Rotate. Very good. It will move towards higher force side. If F1 is more than F2, it will go towards F1. If F2 is more than F2, it will go towards F2. Will the body rotate? I don't think. There is no distance here, perpendicular distance here. So can I say that the body's net force will not be 0, isn't it? F net will not be 0. What about torque? Torque net will still be 0. So body does not have that translatory equilibrium, but it has rotational equilibrium. The body will be in what motion? Rectilinear motion or translatory motion, whatever you want to call it. Translatory means straight line. Translatory motion. Now, imagine there is an object which has two forces which are equal, opposite, but not acting in the same line of action. Rather, they are acting in two different points. What will happen now? F net is 0, but these two forces will create a condition called as couple. This is called as couple. Couple means two equal and opposite forces acting in different lines of action. What is a couple? It is a special condition of torque where there are two equal and opposite forces acting in different line of axis, not in the same point, different points. This is called as couple. And what happens in this case? F net is 0, isn't it? Like how here F net was 0, but torque net was also 0 in this case. But here torque net will not be 0. It means the body is not equilibrium, translatory equilibrium alone, and the body starts to spin. I hope you're getting my point. If there is an object acted upon by force like this and this, it starts to spin. Will it move right or left? No, because there is no force which is making it to move, it just moves like this. I hope you are getting my point, isn't it? Now the fourth condition. Fourth condition is when you have the body which has forces which are unequal, opposite and acting in different lines of action. Now depending upon F1 is more than F2 or F2 is more than F1, the body may move like this also, or the body may come like this also. Are you getting my point? If F2 is more than F1, the body will go like this. If F1 is more than F2, the body will go like this. So there will be a translatory motion also, rotational motion also. The body will be rolling. Don't you understand this? Rolling is different from spinning. Spinning is at a particular point. Rolling is like wheels will roll in the cycle, in the bike, in the car, isn't it? So here F net is also not 0. Torque net is also not 0. The body is neither having this equilibrium nor that equilibrium. So in this case, the body is at rest. It has both equilibriums, translatory as well as rotational. When unequal forces are acting in the same line of action, the body has only rotational equilibrium. When there are equal forces acting in different lines of action, the body has only translatory equilibrium, and in this case the body has no equilibrium. The body is rolling. So when the body is in rolling condition, it has no equilibrium. When the body is in spinning condition, it has translatory equilibrium. When the body is at rest, like whatever examples we solve today, these questions are what? Which equilibrium is that? Both translatory and rotational, isn't it? Because the body is at rest here. Is the body moving here? Neither moving in translatory direction nor moving in rotational direction. This question, all of these questions are what? Even this question. These are the questions from this condition, where neither we have translatory equilibrium, neither we have translatory motion nor we have rotational motion. So this is also there and this is also there. The body is in both translatory and rotational equilibrium. Are you getting my point? Yes. Yeah, because what is the meaning of translatory? Force is 0. How can it have motion then? Translatory motion means force will not be 0. Net force will have some value. If this object is moving this side, it means what? It has a net force in this direction. If the body is moving this side, what is the meaning of that? Net force in this direction. So if the net force is not 0, the body will obviously have translatory motion. If net force is 0, no motion translatory. Net force is 0, no translatory motion. Once again, F net is not 0, translatory is there along with rotational, that's why it became rolling. Are you getting my point? Rolling means translatory, rotational both are happening. Spinning means rotational alone is happening. Translatory means only straight line motion, and here the body is at rest. Got it? Yes, something else you want to ask? So I think today, something you're asking, Nikhila, yeah? Loudly. Torque not be 0. Okay, so your point is torque itself comes from force times distance, isn't it? And force we are saying as 0. Then how can torque be not 0, right? That is the question. See here, you don't confuse in this. I have not said force is 0. I have said net force is 0. This force multiplied by this distance will create a torque. Are you getting my point? This force by this distance will create a torque. But overall this force and this force will not create any translatory motion. Are you getting my point? So torque net is not F net into R. Don't confuse like that. Torque net is F into R plus F into R. Are you getting my point? Torque still remains the same. Force multiplied by perpendicular distance. And force is not 0. Force has some value. Net force only is 0. I hope you get my point. Okay. So if it is clear to you, we can wind off today. And this is the end of this chapter, rotational mechanics.